Okay, so nature of roots. So the number of times a curve crosses the x-axis tells you how many roots there are. Okay, so when we solve an equation equal to 0, we can actually find how many roots there are. So for instance, where this curve is equal to 0 is where it crosses the x-axis, and we'll have two solutions out, won't we? And that tells us there's two roots. When it comes to this curve here, notice it crosses the x-axis 3 occasions, so that means there's 3 roots. Okay, now in order to find how many roots there are, we would need to solve the equation equal to 0. So in the case of a quadratic, okay, quadratics of that form, yeah, equal to 0, we could use the formula method, if you remember from GCSE. Okay, so let's just have a look at a few examples here using this method. So in this case here, x squared plus 6x plus 8 is equal to 0. So remember then, you've got to identify a, b and c. So a is the number in front of the x squared, b is the number in front of the x, and c is the constant at the end. So remember then, with the quadratic formula, it's minus b, so minus 6 in this case, plus or minus the square root b squared, so 6 squared, take away 4 times a times c, which is 8. Okay, and then you've got to divide all that then by 2a. Okay, the whole thing, remember, divide by 2a, and a is 1, so it'll be 2 times 1. So in this case then, we get, well, if I work out that root there, okay, you can do on your calculator, that comes out to be 4. So you get plus or minus then the root of 4, or divide by 2, so we get minus 6 plus or minus 2 over 2. And if you remember then, you take the plus option, or you take the minus option. So in this case here, we get minus 2. Okay, and in this case here, we get minus 4. Now what we've got here is two roots. Yeah, we can see that, and they are different. Okay, you can see it drawn here on this graph. Okay, so we've got two roots, and they are different. And what we say is we've got two real roots. It's important to recognize that these are real numbers. Okay, so you've got to use that word real. Two real roots, but they're also distinct. Okay, they are different. They are not the same. So ultimately we say two real and distinct roots. Okay, distinct just means different. And when it comes to the second one here, okay, well, I've got minus b, so minus 6, plus or minus the square root b squared, so 6 squared, minus 4, times a, which is 1, and times c, which was 9. All over 2a, so that'll be 2 times 1 there, okay? So x will equal to minus 6 plus or minus. Now, if you work that root out there, okay, it actually comes to 0, okay, over 2. And we all know the square root of 0 is just 0. So you get minus 6 plus or minus 0 over 2. And we all know if we add 0, it makes no difference. Or if we take away 0, it makes no difference. So we can sort of like forget about that. Now we can ignore it. So we just get x equals minus 6 over 2, which is equal to minus 3. So notice that we only get one solution out. Okay, and we used to, with quadratics, having two solutions out, yeah? So what we say here is that we have an equal, okay, equal, or sometimes we say repeated real root. And you notice on the graph there, okay, the situation that arises, okay, we have one root essentially, don't we? Okay, because it just touches the x-axis there, yeah? But we say equal or repeated because, you know, if you were to factorize this, you'll notice you'd have two brackets that are the same, okay? It'd be x plus 3, where we factorize this here, okay? And then when you solve it, you have x equals minus 3 out twice, okay? So that's why we say that, a repeated real root, right, or equal real root. But notice that it touches the x-axis there, okay? Okay, one final one. In this case here, we've got, so the quadratic formula minus b, so minus 4 plus or minus the root b squared, so 4 squared minus 4 times a times c. All over 2a. Now, we're going to have a problem here because when I work that out on my calculator, okay, I get minus 64 in here. Now, try and type in square root of minus 64 in your calculator and you'll realise that it won't do it. You can't square root a negative number. It'll say math error. So in this case, you get an error. So what we say is that there are no solutions. There are literally no solutions to this. So we'd say there are no real roots. In other words, we don't have any roots. Okay, look at the graph of it. Think about why we don't have any roots. Okay, by looking at the graph, of course, it does not cross the x-axis once at all. Okay, and that situation arises a lot. So when you get quadratic formula that doesn't work, okay, the reason for it is because you have a negative root here, which you can't do. Okay, it's impossible. So you get no solutions out because there are no situations where that curve crosses the x-axis.